Topic 3. Applications of differentiation and integration in economy and business. In this video, we are going to discuss on how to compute maximum revenue, minimum cost, and maximum profit by using the second derivative test. So first, how to determine the maximum revenue by using the second derivative test. Okay. So to maximize the revenue at the level of production X0, the following condition must be satisfied. So the first one is R prime, the first derivative, equal to 0, and the second condition is R double prime, the second derivative, less than 0. So the maximum revenue is given by R of X0. How to determine the minimum cost by using the second derivative test? To minimize cost at the level of production X0, the following condition must be satisfied. The first one is C prime when X equal to X0 equal to 0. And the second condition is C double prime, the second derivative, at X equal to X0 is greater than 0. Then the minimum cost is given by C of X0. How to determine the maximum profit by using the second derivative test? To maximize the profit at the level of production X0, the following condition must be satisfied. So the first condition, pi prime at X equal to X0 equal to 0. And the second condition, pi double prime, the second derivative, at X equal to X0 is less than 0. So the maximum profit is given by pi X0, and its unit selling price to obtain the maximum profit is P of X0. So how we get Px? Px is given by Rx divided by X. Now let us look at example number 12. So a television manufacturer produces X set per week so that the total cost of production is C of X equal to X cubed minus 195X squared plus 6,600X plus 15,000. Find how many television sets must be manufactured per week to minimize the total cost. So in this case, we want to minimize the total cost. So we are given cost function C of X equal to X cubed minus 195 X squared plus 6,600X plus 15,000. Okay, so the first step is we have to find the first derivative. So C prime of X, we differentiate cost function. So what do we have here is 3X squared minus 390X plus 6,600. So this is our C prime. Okay. So minimum cost is when C prime equal to 0, the first condition. Okay, so when C prime equal to 0, 3x squared minus 390x plus 6,600 equal to 0. So when we factorize, we will get x minus 110, x minus 20. Okay, so x equal to 110, x equal to 20. Okay, the second condition is C double prime. So we have to differentiate again to find our second derivative. So C double prime equal to 6x minus 390. Okay, So we have to check when X equal to 110, our C double prime equal to 6 times 110 minus 390, which is 270. Okay, when X equal to 20, our C double prime of 20 is 6 times 20 minus 390, which is negative 270. So in this case, C double prime equal to 270 is greater than 0. Therefore, the cost is minimum when X equal to 110 units. So, the manufacturer must produce 110 units of television to minimize the cost. Example number 13, the demand function for X units of computer component is given by Px equal to 320 minus 0.1x. Find for question A the revenue function. So for question A, Rx, the revenue function, is given by the quantity X times price function, P of X. So we have X times 320 minus 0.1x equal to 320x minus 0.1x squared. So this is our revenue function. So therefore, the revenue function is Rx equal to 320x minus 0.1x squared. For question B, the number of units of the computer component that need to be sold to maximize the revenue. So the maximum revenue is given when the marginal revenue, which is R prime, equal to 0. So what is our R prime? We have to differentiate the revenue function to get our R prime. So what is our R prime? We will get 320 minus 0.2x. So when R prime equal to 0, 320 minus 0.2x equal to 0, then x equal to 1,600 units. Okay, next we have to prove that when x equal to 1,600 units, the revenue is maximum. So we differentiate once again to find our second derivative. So R double prime will be equal to negative 0.2, which is less than 0. So we can say that the maximum revenue when x equal to 1,600 units. Okay. For question C, okay, find the maximum revenue. So the maximum revenue is R when x equal to 1,600. So we substitute x equal to 1,600 into the revenue function. So 320 times 1,600 minus 0.1 times 1,600 squared. The maximum revenue will be equal to RM 256,000. Example 14, Innovation Sdn Bhd make toys. The demand function in RM is Px equal to 80 minus 0.004x, where x is the number of toys made. Find the maximum revenue and the number of toys that need to be sold. Hence, find the price at the maximum revenue. So first, we are given the price function. So we are given the price function P of x, which is equal to 80 minus 0.004x. So, what is the revenue function? The revenue function R of x is given by the quantity times the price function. So, we multiply x by the price function 80 minus 0.004x, and the revenue function will be equal to 80x minus 0.004x squared. The maximum revenue is when the marginal revenue equal to 0. So, first we have to find the marginal revenue. Differentiate revenue function, then we get 80 minus 0.008x. So, when R prime equal to 0, 80 minus 0.008x equal to 0, then x equal to 10,000. Okay. So, they have to produce 10,000 units of toys to Alright, so when x equal to 10,000 unit, we have to confirm whether the revenue is maximum or not. So, we find the second derivative r double prime of x, so equal to negative 0.008, which is less than 0. Therefore, we can say that the maximum revenue occur when 10,000 units of toys were sold. Okay. And then the question asks, what is the maximum revenue? So what is the maximum revenue? The maximum revenue is when x equal to 10,000. So we have to find R when x equal to 10,000. So we substitute into the revenue function. So 80 times 10,000 minus 0.004 10,000 squared. So answer will be RM 400,000. So the maximum revenue is 400,000 ringgit. And then find the price at the maximum revenue. So when x equal to 10,000, what is the price per unit? So P for 10,000, we substitute into the price function. So 80 minus 0.004 times 10,000 equal to RM 40. Number 15. The revenue and cost function in RM of a product are given as Rx equal to 600x minus x squared, and cost C of x equal to 200 plus 6x plus 2x squared. Find the profit function. So for question A, the profit function pi x is given by Rx minus Cx. So Rx is 600 x minus x square minus cost function is 200 plus 6x plus 2x square. Simplify, we will get profit function equal to negative 3x square plus 594x minus 200. So this is our profit function. Hence, determine the quantity to maximize the profit. So we have to find the marginal profit pi prime. So differentiate the profit function. We will get negative 6x plus 594. When the marginal profit equal to 0, then negative 6x plus 594 equal to 0. Then x is 99 units. So second derivative, to prove that the profit is maximum, is negative 6, which is less than 0. Then we can say that the maximum profit occur when x equal to 99 units. Okay, for question B, currently the company is producing 100 units of product. Should the company increase or decrease the production? So the company should reduce the output in order to get the maximum profit. Example number 16. A company manufactures and sells X transistor radios per week. If the weekly cost and price demand equation are given as below, find the following for each week. For question A, the maximum revenue, and question B, the maximum profit, the production level that will realize the maximum profit, and the price that the company should charge for each radio to realize the maximum profit. So for question A, we have to find the revenue function first. So Rx is given by x times Px. So x times 10 minus 0.001 x. So the revenue function will be equal to 10x minus 0.001 x squared. The maximum revenue occur when R prime, the marginal revenue, equal to 0. So first we have to find the marginal revenue. So we differentiate the revenue function. R prime x equal to 10 minus 0.002 x. So when R prime equal to 0, 10 minus 0.002 x equal to 0, then x equal to 5,000 units. And then we prove that this is the maximum revenue. So R double prime, second derivative, equal to negative 0.002, which is less than 0. Then we can say that the maximum revenue occur when x equal to 5,000 units. For question B, we have to find the maximum profit. So what is the profit function? The profit function is given by the revenue function minus cost function. So the revenue function is 10x minus 0.001 x squared minus the cost function is 5,000 plus 2x. When we simplify, the profit function will be equal to negative 0.001 x squared plus 8x minus 5,000. Next, we have to find the marginal profit. So, we differentiate the profit function. We will get negative 0.002x plus 8. So, maximum profit occur when the marginal profit equal to 0. So, when the marginal profit equal to 0, x equal to 4,000 units. And then, we have to prove that when x equal to 4,000 units, the profit is maximum by using the second derivative. So, we differentiate the marginal profit, then we will get the profit double prime or pi double prime equal. Then we have to prove that when x equal to 4,000 units, the profit is maximum by using the second derivative. So differentiate again, we will get negative 0.002, which is less than 0. So we can say that the profit is maximum when x equal to 4,000 units. And then the question asks for the maximum profit. Then we have to find the maximum profit. The maximum profit is the profit when x equal to 4,000. Then we substitute x equal to 4,000 into the profit function. So we have negative 0.001 4,000 squared plus 8 times 4,000 minus 5,000. And the maximum profit is RM 11,000. And then the price that the company should charge for each radio to realize the maximum profit. So P when x equal to 4,000. So substitute x equal to 4,000 into the price function. Then we get 10 minus 0.001 times 4,000 equal to RM 6.